Hi, welcome back. This is video 2 of the Tic Tac Toe game creator series. I mentioned in the last video that I wanted to spend some time talking about design because I found this subject lacking in my experience learning and following along with Unity tutorials. People gloss over the details and they just start throwing code at you, start building classes. You don't know why they're organized that way. Maybe you do sometimes, it's obvious, sometimes not. And so I think that's a really important part of the process that uh, gets glossed over too much, and you don't get better at it without working at it. So that was sort of the inspiration for this part of the series. If you feel comfortable with your ability to specify how apps work, how to break that out and produce classes from that information, feel free to skip ahead in the series or use the YouTube feature to make my voice go by at 1.5 times or double time. Whatever you like to do to proceed. This is a beginner's course though, so a lot of people would be watching this without ever having to organize their thoughts in terms of design and break things out. And the tendency with beginners is that they're sort of afraid to make classes. You know, they get that one class produced by them in their IDE and they're reluctant to go out and make new classes, and then you end up with this one sort of monolith class that does everything, and it's a big dumping ground, and the methods are too long, and it's just a mess, and it gets much worse as the project sizes get bigger. So I would like to try to avoid that and get people into good practices before suffering through a lot of that stuff. So that said, this game is Tic Tac Toe. We chose it very specifically because it is such a simple game and we want to focus on the other parts. But we have to make sure we understand how the game works, and not only that, that you can explain and articulate how the game works. And I'm sure you can. I know it sounds probably dumb with this scenario, but humor me. Uh, Pause the video, explain how the game works, the rules of it, what to expect at each stage, and we'll talk about that, right? So how would you describe the game? You could say that it's a game board consisting of 9 cells. I chose to call each of these little boxes cells in my design. And that it's a 2-player game, right? And players alternate turns. On their turn, a player will choose one cell to mark as their own. And the game proceeds in this way until either someone wins or the game board is filled up. And then you have to define what it means to win. In tic-tac-toe, you win if you get 3 of your own symbols in a row, either horizontally, vertically, or diagonally. If the board is filled up and no one has 3 in a row, it's a drawn game, and you can start again. Usually players in a human scenario would alternate who starts and goes first each time, you know, because the player goes first has a slight advantage. And that's, you know, that I think that touches it. Hopefully you thought of something similar and described the game also in that way. For the one that I made it such that whoever goes first will be the symbol X automatically, whether it's player 1 or player 2, human or an AI player. So yeah, not too much to the game, and that's what we wanted for a first project. So that said, then I'll proceed to show you the game flowchart that I produced to represent how this works. And we'll go over this. Hopefully it doesn't seem overwhelming, but this was my attempt at describing how the game progresses. And you'll notice there's this start node, and there's an end node, and that sort of encompasses the whole process of what can happen based on whatever actions are taken during gameplay. And so to start, I chose to have a menu. Hopefully that's obvious. When you play a game, there's some kind of menu that allows you to make the selections that you need to get into the game. Notice that the diamond boxes sort of represent decisions, and that's common in flowcharts. Maybe you're familiar with flowcharts or not, but you can certainly Google that if you need a little more understanding. I think they're pretty self-explanatory though. The square ones sort of define steps, and then these diamond ones are sort of forks in the road, if you will. Branches where you take a different path depending on a decision that's made. So we've got our menu, and then we just kind of sit here and we wait until the player makes a selection from the menu. My menu is very simple. You can pick a 1 or 2 player game, or you can exit the app. And if they exit, that's very simple, right? You hit the end node and you're done. Now, assuming somebody's going to a play, you have a 1 or 2 player game. I'm sending them into the game scene, which I have separate from the main menu. I find that more organized than sort of slapping a menu box over the game, but you could do it that way if you liked. Then again, we're at a decision here. Did the player select a 1-player game? It's either yes or no. If they did, yes. If not, then they made a 2-player selection. Let's say they did choose to have a 1-player game. I let you know that there is an AI component available for this app where the person doesn't have to have another human in the room with them to play. They could play alone and have a computer opponent make moves against them. So that's sort of what this branch represents. My game has to, the way I set it up is that it will randomly select one of those players to go first. It may be the human or it may be the AI, and I gave it a 50-50 chance of selecting one of those players. Again, we're at a choice here. This represents when the game started. You're into the game now. Is it the human's turn? And before we proceed, because this is sort of a game loop, let's explore what would have happened if it were a 2-player game. No, 2-player, and again, you could think of this little subset that I'm outlining in the chart as sort of the main game loop. While a game's active and playing, before anybody's won or drawn, you sort of keep cycling through this path. And so this is where you'll spend most of your time in terms of the app's lifetime. So anyways, you're checking if the game is over. It's not, because we just started. So again, we're checking, is it the human's turn? In the case of a 2-player game, both players are human, so you're going to hit this yes. You're going to wait for the player to make a selection. You just hold there until they tap one of the cells. And then you would mark the cell for the player, and you come right back to this loop and you keep repeating. Hopefully that's clear. You see how in this 2-player game, someone moved, you're checking, is game over. And game over is determined by if someone won or if the board is filled up and there was a draw. If it's not, you keep waiting for moves to be made and keep going until the game's over. So we had started with the 1-player branch as well. We got to this point. If it's the human's turn, let's say it was not. Then, obviously, have the AI choose a cell, right? It's not the player's turn, it's the computer's turn. So just like you did when the player made a move, you mark that cell for the AI player, and then you're back. It spits you back into this main loop again. Game over? No, it's not. Of course, now since the AI moved, it will be the human's turn now. You come down into the yes branch. This time you're going to wait for the player to select a cell. You're going to mark it for them when they do. And you're back here again. Next time, the game won't be over. Is it the human's turn? This time it won't be, right? Because each time the turn alternates between player and AI. So it's not the human's turn. You come up here again, AI makes a move, and I think I've talked about that enough to understand how this loop works. Finally, you get to a point where the game is over. You're going to display a game result. You might have a text box that says player 1 wins, something like that. At this time, there is a menu within the game itself to either start a new game or to quit. You're going to watch for that. And if the player chooses quit, I have it spit you back out at the main menu. And then this could represent if you wanted to change from a 2-player game to a 1-player game, or you could also exit at this point and you're out. But if your game's over, you've displayed it, shown the winner, and the player wants to play again, they select that option. You restart the game. This would involve clearing the game board, sort of resetting the state of the game, which player's turn it is, stuff like that. And then you come back into this loop that we already discussed, and you'll basically loop through again while another game's played. And you come out here. So when you make a game flow diagram like this, the key thing is that you're getting all of the potential paths that the app can take. You wouldn't want to miss a case here, because you wouldn't want to miss a case when you were programming the game either. That would be bad, right? It would be sort of undefined what happens when you hit an expected case. That's pretty bad if it's something that is easily anticipated. So we don't want to do that. You want to make sure everything's covered. Because Tic Tac Toe is so simple, I was able to squeeze this flow diagram into one page. In a real scenario, you would have a huge system, and then you might have one document like this to describe each subsystem, so you could have many of these documents that describe your entire app. But since this one was simple enough, I was able to put it in one place. Don't be afraid to spread it across documents. It's better than trying to make these boxes really tiny and barely legible, and you're left with another mess. So that's sort of how the game progresses, right? And then your job next would be to implement this in code. And it's kind of, this is a more friendly format than just writing it out in English text. These decision branches very much feel like programming, right? Like if statements, you might do one thing or another based on a condition. So that's nice, where you can see the kind of progression from a language specification to code. And then you could do something similar. I made something quickly that would represent the classes that you use to sort of implement this behavior, right? We do C# object-oriented programming, so our job is to make these object agents that sort of are responsible, that work together to achieve this flow here. And so that's sort of the next step. There's a whole language called UML. I think it's Unified Markup Language. This isn't UML. They have all sorts of extra information. You can look into that. I tried to keep this as simple as possible, and so I'm not claiming this is valid UML. But the idea is that you break you define your objects rather, right? And in here I listed some of the public variables. That's all I defined for my classes. I didn't list any of the private stuff. I just put my public members here, and that keeps the size of the classes small. And it might be a little overwhelming to see so much information at once. So I tried to make this very beginner friendly, but you can get the idea. This game manager class is sort of it's very common when I make games, or when anybody does, to have a game manager that sort of manages the overall state of the game. It keeps track of scores or whose turn it is, and it defines how to proceed between each state as things change during the game. You know, a player makes a move and then it's going to switch to some other player's turn, and you might have a state for when the game is over, when the game is won, something like that. And looking at the members of the class kind of gives you an idea of that. It defines, the way I did it anyway, the public interface to the class. So users of this class could see the kind of features they have available to them, and they can use them as they like. Ideally, you want to keep these public interfaces very small because it makes the class easier to work with. You could imagine if there were 100 entries in here, that would be overwhelming, and it would take you a while to read it, and think if you have to call things in a certain order, and then you have worries about that, and you don't want that. It's very bad. The goal is to make a bunch of very small, very defined, focused classes that do a small job. And that's sort of the point of computer engineering, is that any job is easy if you can break it down into very simple steps, right? Because by definition, those steps are simple. You might have a ton of them to do something complex overall, but if you can break each part down into something really simple, then you can do about anything. And that's where the power lies. So I had this colors configuration class that is a nice little, it allows me to change the color scheme of the app on the fly. I use a scriptable object. If you don't know what that is in Unity, don't sweat it. But I basically store some color values in here, and then I can have the code reference these. And if I don't like it, I think some color scheme's ugly, I can just change it in this one place, and poof, it takes effect throughout the app. So that's handy. We had the main menu manager. This was the initial menu that the player sees, where they select one player, two player, or to exit. I should note that the top section in these boxes represents the members, and the bottom section represents the methods, the public methods available. So, yeah. I defined a player class to represent the different player types, which are either human or AI, as noted in this enumeration. Those are my two types. I made this factory class. If you're not familiar with design patterns, the factory one's a very powerful one that you should, I would say, look up. It's a nice first design pattern to learn. It's pretty simple in nature. It basically packages up a complicated construction process and gives you a nice interface to that. So instead of creating players in my game manager class each time the game is initialized, I can just make one call to this get players method in this factory, and it just gives me the players for the game. I don't have to have any of that logic bloating this class, and that's great. Makes the class too big, makes it ugly. If you ever change how players are constructed, make new types, whatever, the game manager class really doesn't have to know anything about it. They're going to get players for the game. So that's nice. Game menu manager, I had all private variables, so I didn't list anything here. This would be that in-game menu I told you about, where you could select a new game or to quit after a game's over. Then you can kind of think of these three boxes here as the game board itself and its components. So we have a game board for the game, a 3x3 grid with cells. You see this cell class. Cells can be reset. They can have a symbol set, either X or O, or I made mine more general. You could use a different symbol if you wanted, but I'll be using X's and O's. And there's a highlight option. When a player wins, I like to change the color of the cell to make it very clear which line they won on. A game symbol again, we're going to know them as X's and O's that are red and blue, but with this kind of setup, I could change that to be the first letter of my name or another color. You could imagine if you wanted to enhance the menu and allow players to pick a letter symbol. Maybe they wanted it to be their first name, and then they could pick their favorite color. You could do that. We're not going to do that, but because I made this really generalized, it would be pretty easy to do that. And my game board, right? It's got 9 cells. This available cells starts as all cells available, but as players choose cells, they'll be removed from this list. And this helps me verify when a move is made. I can ensure that the cell hasn't already been claimed before I give it to the player that is requesting it. And that's important. You're going to have to watch for all these sort of scenarios of improper usage, and you definitely want to test that when you have your app running and try and it's not easy to think of sometimes because we always play it the right way. We're envisioning the right way, but you got to think like a user who may not know, or it pushes a wrong button. Anything can go wrong, we know. And finally, I made this win analyzer class that'll sort of, given the cells claimed from corresponding to a board, we'll scan over it and tell us if someone won or not. And if they did win, it will give us the cell numbers of the winning pattern. So that would be a size of 3 to make a win. And that mostly describes it. I did mention that I had an AI player type, and the logic for it was so simple in this app that I didn't make a new class for it. In reality, if you had an AI system, it would be broken out into its own class, but I didn't do that here just because the code was so small, but that would be a good one to break out too. Then note that there's nothing magical about the way that I broke these classes out, right? This is just the way my mind thought of the Tic Tac Toe game. It's what resulted when I made the flowchart. How do I achieve this? What kind of agents would I like to have that would make my life really easy for implementing this game flow diagram? And then I came up with this, and these produced very small classes, and that works well for me. That's my goal. I want my classes to be super small. I think all of them were under a couple hundred lines. That's sort of my weird point, is if I have a class that's going over a couple hundred lines and I'm thinking I'm trying to do too much in this class, I can probably break this out into something smaller. It's kind of analogous to when you make functions. For me, they definitely shouldn't span more than the screen size, and I don't even like them to be more than a few lines long. If they are, that's fine. If I can refactor it, I do. But yeah, you don't want to be scrolling to read one function. That's usually a really bad sign. And same thing with classes. If you have classes that are thousands of lines long, think about that when you're assigned to work with a class like that and what a headache it is. And you have to think about something so complicated to understand it, and it's a mess. It's not good for anybody. So, and I'm not kidding. You will find classes that are thousands of lines long, and I don't understand why people do that. I do in a sense, because in the business world you have to get things done, but in the long run, stuff like that hurts people. It's my belief that it consumes more time than had someone refactored it, took the extra time to refactor. But, that's my mini rant. I'll leave it at that for now. The other part of the design process is sort of that you define what your screen should look like. You have an idea of what you want the user to see, and when you go to implement this thing, it's already defined for you. You know exactly what to put, where to put it. Notice I didn't put dimensions in here, right? If you want to be really specific, professional, you could say, maybe this is a third of the way over of the screen, a quarter. However, however detailed you want to get with your specification. This is meant to be extremely simple, and so that's what we're going for. Main menu, we have a title text. We have 3 buttons. I chose to put them in a horizontal arrangement. You could have done 1-player, 2-player exit. Whatever is visual appealing to you, you could, if you really cared, look up UI guidelines for design. I'm not a UI, UX expert, so you feel free to consult one of them to get the optimum layout appeal, if that's what you're going for. On my other screen, this app is really simple. I have a menu and I have a game screen. And so when you're in the game playing, this is what you're going to see. I wanted to have a field that says whose turn it is. So you could imagine this player 1 value would toggle. It might say player 1 and then player 2 after player 1 makes a move. When player 2 makes a move, it would go back. I have this status text which I start as being invisible, that's why I put it in brackets, but when someone wins it will list who won the game. And then I had mentioned the new game and quit options. So when the game's over, you have a choice. You can quit back out to the main menu, or you could select a new game, in which case you stay in the game scene here, and it just clears the board for you, and you start anew. And it will tell you whose turn it is. If you chose 1 player, you'd still be in 1-player mode here. So if you wanted to change the number of players, you would quit out to the main menu first, and then you could make that selection again. And that's how the game works. This should look very familiar. This corresponds, remember when we did that demo in the first video? This is what you saw. We ran it in Unity. Feel free to refer back to that if you'd like. It was colored, but essentially it looked just like this. So we have our screens. We know what the app should look like now. We've defined in terms of language what the Tic Tac Toe game is, how it works. That's the start, right? That was our language specification. All the people we were working with would agree to those rules. That's how the game functions. Then we kind of used some diagrams to make our lives easier when we get into code. We've got our class diagrams, right? So you can imagine that I would make classes with each of these names defined in here. 1, 2, 3, 4. Well, this is an enumeration. This I actually implement in one of the classes, but so we got a handful of classes here, and we'll make classes for each of these. And that'll be very helpful for us. We'll know the public interface, so we can make these our public fields, and then we'll use private stuff to actually implement it, and we're free to do whatever we want there as long as we uphold this public interface. That'll be great. And then we have our flowchart of how the game should proceed, which will also help us when we're writing code, doing some of that private implementation that I was telling you about. So I think this gives us all the tools that we need to start coding the app. And again, people often just go right into coding the app, and they're not saving time when they do that, because you run into walls when you do that. And what they're actually doing when you start in code is that you're basically doing the same thing I showed you, but you're trying to do it at the same time that you're writing code. And if that sounds messy and like it could be confusing, it is. You can't keep track of all of this stuff in your head while you're also trying to think of the code to write. Maybe you can with a Tic Tac Toe game. You're not going to with any industry problem. It's too much to juggle in your head. So yeah, I wouldn't necessarily recommend going that way. I'm not going to say I haven't done it. I certainly have, especially with small apps. I'm not saying that I always write everything out, but certainly if things are complicated, something like this really helps me organize my thoughts and go into the IDE for coding with a purpose and a sense of direction and a reference if I forget that vision or become confused on a point. So I hope that you found is helpful. It helps you organize your thoughts. I recommend it even when you're doing your own apps for other ones. Just try it. See if you could list all of your thoughts out and in a really nice, organized way. Maybe try giving it to a friend or share your document with me. I'll tell you if I think it, wow, that looks really clean. I definitely understand what you're doing here. Or similarly, like, hey, what about this case that you didn't address? If something's missing, or if it's just like, this is really confusing. And maybe you thought my diagrams were confusing, so feel free to give me feedback so I can make mine better. Maybe there are parts of this that just didn't make sense, and I'm not saying I'm perfect and that I always get the designs right either. No one does. So as usual, I appreciate your feedback. I hope you found this useful. I think in the next video then we'll probably start getting into code. We'll make a new project, get those classes going, and do the fun stuff. Cool, thanks for watching.